Okay, we're going to get started. Welcome to DETNET in Madrid. Appreciate everyone being here on a Friday afternoon when it's really gorgeous outside and it's a little dark or bright. So really appreciate everyone showing up both in the room and online. I'm Lou Berger. This is Janos Farkas, and we also have our secretary Schuler in the room. While it's the end of the week, and you're probably familiar with this, we do have rules that govern our participation. I'm sure everyone has seen the IETF note well at this point. If you are not familiar with our rules, I ask that you go to the IETF webpage and familiarize yourself with the different rules, the different best common practices. Basically, everything you say here is a contribution to the IETF and is governed by these rules. Also, we are being recorded, so it becomes part of our permanent record. Similarly, we have rules related to how we interact with each other. And it's very important that we treat each other with respect and professionally. And when we have technical discussions, they may get a little heated, but please keep personalities and personal comments out of it. Keep it professional. And similarly, there are documents that guide this. You can look at the BCP online as well. It's the end of the week. Everyone's really familiar with this. The thing that I'll ask is if you have not joined the either the hand tool or online on your computer, please do so now. When it comes time for discussion, we are going to do integrated queue management between those in the room and those remote. Also, it helps get us the right size room, which is sort of comical today because we have a room that we could, I don't know, I think we could fit everyone in one row, let alone this whole auditorium. Yeah, I see, actually, even though there's lights in my eyes, I see people back there sort of waving. It's back quite a distance. Please join us with joint note taking. So if you're on Meet Echo, there's a nice convenient button. If you're not, it's off our agenda page. You can find the meeting note page. Please help us capture the discussion. You don't have to capture what's on the slides, but just after each slot, just help capture the discussion. And if you are making comments at the mic, please make sure your name is spelled properly and that your comments are appropriately captured. We have a pretty full agenda, which is great, particularly, again, late on a Friday. We have a number of talks related to, a number of slots related to queuing mechanisms that tie back to our enhanced data plane. We have said this a couple of times, I think, on list as well as in the interim. We now believe we're at the point where we should be considering adoption of solutions. And it's very important that before you ask for adoption, that you identify where you fit into the categories or subcategories that are identified in the taxonomy document. Part of that importance is that we are hoping we do standardize at most one solution per category. We really don't want to introduce confusion by having multiple solutions that really are serving the same purpose. The different categories can be seen as serving different purposes. So we would like to have our now individual drafts self-identify which category you go into, and then part of our adoption process will be making sure that the group believes, number one, that categorization is appropriate, and number two, that is the solution that the working group would like to move forward for that category. Okay. When presenting, just a reminder, focus on what's new and what remains to be, what's needed to close. For the non-working group documents, particularly the data plane drafts, we're hoping you'll talk about how you relate to the categories and satisfy the characteristics of that category. So we have 3 documents that have gone through publication request. I actually see we have the wrong version uploaded somehow because this says there's a discuss on one document. The discuss has been resolved. So everything is moving along nicely, and we really appreciate the hard work of the authors, the contributors, and the general working group in bringing these documents to the point where they are with the ISG. And yeah, we do need to carry it over the line and make sure to respond to any comments that come up. The authors have been doing that, and but we really want to applaud those who contributed to this work and thank them. We're here to produce documents, and we've been successful here. It's notable that these documents came into us, the raw documents came in through another working group, the raw working group, and been merged back. And so this is actually successful execution of that plan that was laid out by the prior AD. I don't remember if it was John who did that to us or not, but we'll send him the blame either way. But anyway, so that's great. Nothing else of note here. We do have a few things that are not on the agenda. We have the scaling requirements. The intent is to update that based on once we have solutions. The topology Yang model, we have not heard from, I don't believe we heard from any of the authors on this, and we really would like a status update as part of each meeting to make sure that the document is moving along. I don't know if we have anyone online who is a contributor to that document.
I do, yes. This is Xusong. I'm online.
Hi, Shusang. Welcome. Please go ahead.
Actually, because this document is separated from the DETNET Young model document, so maybe in next meeting we can have a presentation about the progress of this one, and to especially to see whether this is the direction the working group expect.
Okay. Yeah, we're very interested in hearing about open issues, next steps, and how we can move it forward. Confirming that the content is well aligned with the intent of the working group is great. I think that's a call to everyone who's a participant to go read the document and see if you think it is aligned with what you believe the needs are. I'll point out that there are some things related to queuing parameters that those who are working on queuing solutions might be interested in making sure that there's nothing there that they see as problematic. Thank you, Shusang. We have a couple of expired documents. At this point, we are planning on marking these as dead. We don't see, at the last meeting, we said, please, people pick it up, contribute, revive them. Since that didn't happen, we are going to mark it as dead. That doesn't mean it can't be revived in the future, but we are not seeing any active contributions on these at this time. If you are interested in working on the document, you can jump in. Just send something to the list. We can get you the source is part of Data Tracker, so you can pull it down and start working on it. We are contribution driven, so please feel free to jump in and help us move forward. We did receive a liaison. They are asking for views on a gap analysis that was provided. Speaking of being contribution driven, we would love for anyone who is interested in this, actually we'd ask everyone to take a look at it. And for those that are interested and think they have something to contribute related to either the gap analysis or putting forward a draft response, to send a proposal to the list. Again, we are contribution driven. So for us to respond, we do need someone to take an action, to give us a proposed response. And it also would be good to hear from anyone who is working in ITUT to raise any of the points they think really should be discussed here, to raise it on the list. I know we have some people that work in both groups. It's great that you're here. Thank you. Feel free to start the conversation on the mail list. This is just a reminder of our IPR process, where we poll both on adoption and on last call. If you add new contributors to a document after last call, it's also good for at that time for the new contributor to make a statement on whether or not they believe there's IPR related to the document. That will prevent any last minute surprises when we go to last call. As a reminder, if you are not presenting, please send something to the list at the IED cutoff point. At the IED cutoff point, you will know whether you're going to ask for a slot. It's usually the same day that we ask for slot requests. So if you're not going to ask a slot, that is the time to send a status update. The reason for that is it gives an opportunity for some discussion to happen before the working group, rather than for there to be a surprise in the working group and then not have an opportunity to discuss that. We do have online resources. I suspect most are familiar with them. Through the IETF, the chairs have access to resources that can be used for both informal and formal meetings. If you would like to have one, please contact us. As you know, we've made use of formal interims as well as informal discussions in the past. And finally, as a reminder, we have the TSN, the joint DETNET TSN workshop tomorrow afternoon. We welcome everyone in the room to come join. There is a registration that is, I don't know if it's strictly required. If someone has not registered, I'm looking at Janos. If someone has not registered and wants to attend, what do they do?
So actually, we would like to have badges, and it would be good to register. And the other thing is, it is in person, and there is an upper limit in the number of participants in the room. So we want to know who comes.
But at this point, we still have room, right? We still have slots?
As far as I know, there is a queue.
Oh.
But I don't know the full details.
Okay. Well,
please go ahead, and everybody is welcome. So we will figure it out.
Yeah. You've traveled all this way, might as well get a little extra value from the trip. So with that, we are ready to move on to Jinu. I'm doing it.
So where is the venue for tomorrow's workshop? Where's the place?
Yes, it is in this hotel, and please check the webpage for all the details. Actually, it is the room L Escorial, but it's on the.
Okay, thank you. Hello, everyone. I'm Jinu. I'm going to present to you about the taxonomy draft first. So it is now in revision 4. Yeah, it has been started as a chair's request. And on the January 24th. And then it has been like 1.5 years so far. It has defined 1 performance-related categorization and 6 functional categorizations, criteria to be exact. And it has specified 2 reference topologies. And recently, it has specified suitable categories that are 7. How have we derived these 7 suitable categories are well described in the previous materials. So you can refer to those previous materials. So I'll focus on the changes for this meeting. The revisions on this draft, fourth revision, there's not much difference. We have defined 2 new terminologies that are regulator and scheduler. But these are rather important terminologies, so I want you to look into it. So the regulator and scheduler are defined as such. Regulator is a functional entity that makes the arrival process of a flow conform to a predefined process, whatever it is. So the regulator here is synonymous to the shaper. Okay, this is the regulator or shaper. And another terminology is the scheduler. The scheduler is a functional entity that determines when a packet is transmitted. So it decides the order of the transmission or exact time of the transmission. So it is synonymous to the packet scheduler. The reason why I try to emphasize on these 2 terminologies are some of us are confused between the shaper and regulator, shaper and scheduler. So I want to try to make it sure. So that's the new terminologies that has been defined. And this is very important terminology. Suitable category has been revised slightly. It has been defined before as the laser point does not work. Anyway, suitable category was.
There's something flaky going on in the.
Okay.
The pointer doesn't work.
Yeah, we're having some problems with the infrastructure. Like you noticed the timer froze a moment ago, and they're saying they're having some problems in the NOC.
Okay.
So
Okay.
I could try to take it back and do it manually.
Okay. Yeah. So I will go fast as possible. The suitable category was a category within which.
Just tell me next.
Okay. It's okay. Category within which all the solutions are suitable. But that was a little wrong, as you can see, because even within a suitable category, there can be some solutions that aren't suitable, that are not suitable. So the suitable category has been changed to a category within which solutions can be suitable for deterministic networking. So these are all the changes we have made in the first revision. Yeah, next slide, please. Thank you.
So I'm in Q. Why not just use shaper?
Why do we not use the term shaper?
Yeah.
Because the regulator and shaper are the same thing.
Right, but I think most of us are familiar with the term shaper.
Oh, yeah?
Or shaping. At least that's pretty common to me.
Well, the term shaper is kind of intermixed meaning. Sometimes the shaper means packet scheduler in some literature. And the regulator is quite strict in the sense that it is strictly distinguishable from the scheduler. So I prefer the term regulator.
I think that's fine, but just make sure that explanation is in the document.
Okay, okay. I'll try to make sure.
Because I think you're going to get that question again.
No, you have to go to the floor mic.
A shaper is for a single flow. A regulator is a set of flows, so it has better scalability.
Well, I would say the number of flows doesn't matter here. Yeah, it doesn't matter. How many flows are there? It is not concerned here.
Why not? I mean, the regulator were a significant improvement, right?
Technologically, I think there's no distinction whether there are many flows or just one. It's an implementation issue. You can regulate multiple flows in a single FIFO, just like ATS and TSN teaching.
Yes.
There are some other ways of implementation, but these are all implementation specific.
But if we compare, for example, just ATS with RSC 2211, which integrated services, that's kind of the regulator versus shaper comparison. So that's why it's certainly useful to have both of them, because if a particular algorithm doesn't consider the use of a regulator instead of a shaper, it seems like kind of an older, less preferable approach.
Yeah, I think you have heard about the token bucket shaper, right? The old classical token bucket shaper is per flow implementation strictly. So a shaper can be applied to multiple flows or a single flow. That depends on the implementation. Okay, I will try to clarify why a shaper has not been used here. And if it is proper, it is appropriate, I will change it into shaper if that's more comfortable to you. Okay.
I think just being clear is good.
Okay,
And by the way, I do agree with your response.
thank you. Okay, let's move quickly. Next page, please. Yeah, these are abbreviation I have newly created, but no new meanings here. You can just take a look. And this is the so-called 7 suitable categories we are so focused on. How these are derived, that I will not tell you this time. You can take a look at the previous slides in the previous meetings. Yeah. So the yellow boxes represent 7 suitable categories. Some are larger categories, some are smaller. For example, the third one, the right bounded suitable category, is kind of high level category, while the others are lower level with a lot of criteria involved. Anyway, these are suitable categories. Next page, please. Yeah, that concludes the presentation of the taxonomy draft. Future plan, stabilize, and then maybe you can start the approval process. Yeah. Again, this document is not to nominate or select or recommend candidates for suitable categories. It just plainly lists the suitable categories. Thank you.
What do you think is left to stabilize?
Just like the terminology issues, just like shaper, regulator.
Okay.
Yeah.
Great, thank you. Any other, Torlis, you're still in queue?
Yes, I have in my slot a couple of things that I think could be improved in the taxonomy right after going through the application of the taxonomy to the 3 drafts that I have. And so that would be my proposal in terms of what might still be something to look at for the taxonomy.
Okay, let's discuss with you after your presentation. Thank you.
Treasure from ZT, please turn back to the page, 2 pages before. The category.
Oh, I can.
Category, right?
No, it's me.
No.
Yeah,
Yes,
this
You
one.
just-
So as we all know that in FRC 8655, the goal for the DETNET queues is to achieve the banded latency. So why we have the unbounded?
Unbounded.
Unbounded.
Yeah, that's a good question. That's very important. That's why I have specified the meaning of bound
Yeah.
in the upper right corner of this presentation. The time bound, I think while we translate it to PDF file, there are some errors. But anyway, the time bound, a time bound is defined as the latest or earliest time a packet is allowed to be serviced. So it is not actual service time, okay? The packet is allowed to serve next to a so-called eligible time, but it has to be served before some deadline. So these are virtual times. So some of our solutions do not have such time bound, but some of our solutions have. That's the one criteria that we categorize all the solutions into this taxonomy system.
Yeah.
So my answer to you is that even without time bound, we can actually limit the end-to-end latency bound. That's what suitable category 1, 2, 4, 1, 2 are doing.
Okay.
Suitable category 1, 2 are doing.
Okay, so it's different from time bound and latency bound, right?
You can say that.
Yeah.
You can say that.
Yeah, maybe better to clarify in the terminology.
Mhm.
Okay, define.
Oh, you have more questions?
Yeah, divide in terminology. Yeah, thank you.
If you have a suggestion on how to improve the terminology, please send it to the list. Thank you.
Okay, thank you.
So this is actually indirectly from Xiaofu. It reminded me that, or reminded us that RFC 9320, which is one of our RFCs, uses the term regulator.
Oh, I see.
So I think just putting in a reference to that is all
Okay.
that's needed. So thanks for that reminder and clarification.
Thank you, Xiaopu. Okay, I think we are done.
Okay, so you're next up also.
So I'm going to present to you the so-called stateless vacuuming technology. This is one of the solutions that we are proposing to the working group. And okay.
Try again. Try the.
This one? Okay.
Yeah.
Oh, it works now. Yeah.
We'll see.
So you can take a look at the history of the syscore. We call the solution syscore for short. It is not very short, but anyway. So you can take a look at the history. It has been quite a long time. We have been discussed this solution through. It was actually hot topic before IETF 109, but after that, the debate has been quite reduced. So what is the change in this version? Almost nothing. So section 6.4 has been slightly elaborated, but the elaboration, almost all the elaboration goes to the specification that syscore belongs to the one of the suitable categories defined in the taxonomy draft. That change reflects the chair's request. So the syscore belongs to suitable category 1, that is flow level, rate-based, unbounded solution. Syscore is the only solution currently being suggested in the first suitable category. So this almost concludes my talk, but because I have some time, I will go through the key idea of the syscore. Actually, if I explain this part very in detail, it takes very long, but I will go with as quick as possible. I hope you capture the idea. I hope you capture the idea. It may be difficult, but I hope so. So what is the latency bound guarantee? How do you guarantee the latency of flows? All the different flows with all the different bursts, different packet lengths, different path that it has taken. So it has all the uncertainties when the flows joins in certain node of a large network. Then it boils down to the solution, how to resolve the burst collision. Because in traveling the large path, the long path, the bursts accumulated within a flow. And even if the flow were very smooth at the beginning, it becomes bursty sooner or later. All the bursts can join a certain node at a certain time, then we call it burst collision. So the congestion control or latency bound guarantee or G2 guarantee That is how to solve the burst collision. Let's take a look at this example. It is a very simplified example with 3 flows. 2 flows, the blue and orange flows are bursty, but the green one is not so bursty and very generic, very smooth. How will this package be scheduled in the output port? So the left part is the input port, the right part is the output port, and the square, the blue, orange, green square represent the packet length. Okay, so the area of the rectangular is the packet length. Anyway, in syscore, we first decide so-called finish time. Let's call it FT, finish time. This is not a real service finish time. This is just the ideal, virtual time. How do we decide finish time? We first imagine a link dedicated to a flow, but the link capacity is different for all the flows. It can be called service rate overflow. So you can see that blue flow has smaller link capacity, while the green one has larger service rate. In that case, we can service this packet just like there is only one flow. For blue packets, there is only one flow. There's only blue flow in the link that is exactly same size with the service rate it has assigned to. If you serve that way, you can define so-called finish time of each packet. I just noticed that there are only one packet. Finish time is described. That is first blue packet, and we will use this finish time as the actual service order of these packets like that. So here in the previous slide, the first blue packet has the smallest finish time. Or is it orange one? I'm not so sure. Or anyway, the blue packet or the orange packet has the smallest finish time, okay? And then the green packet comes next. This is represented in this slide that all the packets are ordered with their FT, finish time value, and then served with their FT work conservingly. That is, do not waste any link capacity. Just serve the packet as soon as possible, but according to their finish time. Okay. If you look at this service order and their service pattern, you can see that the green packets that arrived smoothly leaves the node smoothly without any burst accumulation. So in that sense, the green packets are protected from other bursty packets, other bursty flows. More than that, the link capacity does not get wasted. And this is the core idea of the fair queuing. This is core idea of the fair queuing. You may heard about the round-robin schedulers, like deficit round-robin, weighted round-robin. And these are all the approximation of this fair queuing. Okay. So this is the core idea of the syscore. And more than that, it is stateless in core nodes by marking the finish time value in the packet as packet metadata and update the packet metadata in a node with some pre-specified value, so-called delay factor. So by doing that, all the flow state should be maintained only in the entrance node. And within a core node, we don't need to maintain flow states. We usually believe that number of the flows in core nodes should be around millions or even more. So stateless core is very important. So if you have understand what I have described so far, you can understand that syscore has a simple admission control procedure. Only the sum of the service rates of the flow should be less than the link capacity. That's the only requirements that we have, which can be fulfilled by any admission control like RSVP. So it has simple admission control procedure. And it has excellent flow isolation property. And it has flexibility to adjust end-to-end latency bound by setting the assigned service rate. So you may ask that the flows with small arrival rates with strict latency bound, how can we serve? It is very simple with syscore. We can assign service rates regardless of the arrival rate. So we can separate those two values, and we can adjust the latency bound freely as much as we can. And again, it has an excellent statistical performance due to its work-conserving nature. If you have heard about the Little's law, that is written below in the slide, in average, the buffer occupancy equals to the arrival rates times the average delay. So because syscore has the lower average delay, it has lower buffer occupancy. That's another advantage. But it has shortcoming. It has complexity. What is it? It's that we need priority queue to shuffle the packets according to their finish time value. So that's the complexity, and it's the major drawback, I admit it. But somehow, the current technology allows the implementation of PI4, the priority queue. The complexity of the priority can be around 2 times as much as FIFO, first in, first out. So it can be a big deal, but it can be negligible. And another one is control plane complexity, but it is, I can say it is not that much, because all we need to do is to admission control. I believe that other solutions need much more complex admission control procedure. Okay, so I have more slides, but the time has come, so I will stop here. You can take a look at how the syscore conforms to the scaling requirements draft that Peng is working on. So this is the requirements for scaling, and again, this is the restructured requirements, and syscore meets these requirements with each. That's all I want to say. Thank you. So Drift is now very stable, I think. Thank you.
I may have missed it. I think you did it in a previous presentation.
Yes.
But which category does this fall into?
The first one.
Great. Thank you.
Flow level, rate-based unbounded.
Thank you. Xiaofu?
Hello. Hello.
Yes.
Jilu.
Yeah, hello.
Basically, I agree the idea of Cisco and think it can work.
Thank you.
However, but I still think for the control plane admission control, for the admission controller, I think it may still need the bus resource, not only the service rate. I have in the previous meeting, I mentioned that there may be too many arrived bus at the same time reach the intermediate node, and that may exceed the buffer capacity of the node. Do you think so?
So I think your question is about the admission control.
Yes, I think it will rely, it will depend on another source type, resource type that is the bust.
Well, usually when you do the automation control, you control the arrival rate, you control the maximum burst, and additionally, optionally, maximum packet length is also controlled. So in order to control the maximum burst size, you have to have a kind of shaper or regulator outside of the network or even at the source. So that is given.
Yes,
Yeah, it is assumed to be given. The regulator outside of the network is given. It is necessary in order to conform to the automation
yeah,
condition. Yeah.
yeah. I think during the past computation, it will still need the control for the bust resource when you compute the path.
Oh, yeah, yeah. I see. Okay. Yeah. Yeah. Just like what you said, the arrival flows, all the arrival flow have to conform to the arrival condition that it has contracted with the automation control entity. That's for sure given. Yes.
Okay, thank you.
Thank you.
Thank you. Shafu, I'm trying to pass you control. I'm not sure it's working. Oh, you're here. Oh, no, I'm sorry. It's Peng.
Yeah, it will.
I'm
Okay,
confused as who's presenting. My apologies.
okay.
Yeah, see someone in the queue.
It's okay. We have to move to the next presentation. We're out of
Okay,
time.
sure.
Whoever's in the queue, if you could take it to the list. The wrong side. I don't know how to stop the sharing. Share slides. You should try. For some reason, I'm having this is not working well today. Ah, great. Thank you. 4.
Okay, this works. This is Peng from China Mobile, and it's about the deadline-based forwarding. Can I control it? Yeah. Okay. So this draft has been updated from version 14 to version 17 with some editorial modifications, but without so much structure modification. Yeah. So here's a briefly overview of this draft. It has 3 parts. One is the packet deadline, including the arrival time, planned residence time, and the latency division. And the second one is to insert the packet into the sorted queue or approximately made sorted queue based on its deadline. Third one is all the eligible arrivals must meet these conditions. Also has 2 ones for the PIFO and another one for the RPQ. So finally, when actual times violates eligible arrival, take reshaping or latency compensation. So here's a updated about the grade topology according to the taxonomy draft. So here we give the examples that today's level choose based on per hop latency bounded of each type of the flow, including the audio, video, and the control flow. So here's a table, and for some of the flows, we resolve some results for it, but for some of the flows, we needn't to reserve the specific results for it. So we can calculate the bounded delay and the jitter accordingly. And this is the evaluation on the ring mesh topology, which was presented in the last meeting, I think. So we just also give the examples of it. So in the ring mesh map, there's 14 hops in the ring network and 4 hops in the core network. So we can also calculate the bounded delay and the jitter here. Okay, here's the analysis of the functional characteristics according to the taxonomy draft. So first, it is non-periodic. The scheduling power of EDF is measured over an arbitrarily long non-repetitive time duration, and it is class level. The flows can be grouped by similar delay levels provided in the network, and the packets will be provided the service based on the delay level without checking flow identification. And it is at least the right bounded. So for the deadline, we can easily imagine what it is. So it can, for the on-time model, due to the further limiting the minimum, the bound, so it is bounded. So it maps to the first category with the in-time model, and it will map to the fifth category with the on-time model. So it depends on the 2 situations for these solutions. And here list some comments in the past meetings, and we didn't receive any new comments from the last meetings. So not sure if the adoption work will begin after this meeting, but this document, the authors of the document want to this draft to be adopted. And any comments or questions?
I guess one comment is that you said first category and Gino said first category, and we wanted to have ideally one.
Okay, yes.
But yeah, we wanted to progress with adoption, and we have to figure out the method on.
Okay, so maybe more discussion just about the first categories. But this draft has 2 models, so maybe we can modify or there's, I think, some of the discussions within the co-authors and also with, okay, Gino, please.
Just a clarification.
Yeah.
My list is different from this list. Okay.
Okay. So
So
this first is not the first of
you're
it.
separated.
Okay. Oh, sorry. So just for the in-time model, it is the right bounded category, and for the on-time model, it's the class level non-periodic bounded category. Maybe different from the.
Maybe let's discuss it a bit further on
Okay.
the list to clarify.
Okay.
Different lists are not helpful. Okay.
Sure. Thank you.
Any last questions, comments before we move to the next one? Okay, then I share your next. Now I'm getting the same error.
I can do it.
Okay.
Okay, so it is a time slot queuing and folding this draft, and also not so much modifications from version 10 to version 12 here. And also a brief overview of the mechanisms. So the key design of these solutions is about the OP orchestration period between the adjacent nodes. And so it set up the base time slot mapping of it. And then it needs to set up the folding time slot mapping for each flow. finally insert the packet into the queue. There is a scheduling period in it, and based on the outgoing time slot ID. This method has some similarities with the TS and also the CQF. It's just to divide the high priority class in the TS into multiple queues. So we can see in the figure from the 0 to M. So it can be divided into M queues, but all these queues are to deal with a deterministic flows. It's based on the basic gating cycle, but there's no gate control list, so it is needn't the synchronization. When the M is 1, so it looks like the TS. Different is that when we insert some new flows into the TS, we may need to recalculate the control list. So the scalability is designed to be better than it. And for the CQF, so first we divide the higher priority classes into more queues. And for these queues, they just go into a round robin queues like the CQF. But it's not really the same. So there is a scheduling period and also for the OP. So that's the difference with the TS and the CQF. So for the grid topology, it is. Okay, yes, please.
Florian?
Maybe for the slides.
Yeah,
Okay.
Florian Kauer from Merlin Electronics. My question that confuses me a little bit that you say it's M is equals 1, and also in the taxonomy draft there is mentioned 8 queues for TAS.
Yes.
So, I mean, we have 8 traffic classes, so we have 8 queues with TAS, but here you say 1 queue. That confuses me a little bit.
Okay, Shaf, do you want to say something?
Yes, I think this question I can give a brief answer. For TS, it actually mentioned there are 8 queues, but just only one of the 8 queues is for the scheduling traffic. The scheduling traffic is the deterministic flow.
Okay, this is not what how I understand TAS, but we may take this offline. Thank you.
Okay.
Okay, thank you. We will move on. So here we list the situations about the grid topology, which is the updated content. That here's the table for the flows of control and the audio and the video flows. There has 50 time slots for them. So we first deal with the control flow and the audio flow, and then we put the video flow in the last. So here it is shows a result of the calculation of its delay and also its bounded jitter. And for the ring mesh map, okay, this was also printed in the last meetings. So here we list at the same give an example how we put these flows into the corresponding time slots, so we can ensure the delay and the jitter here. Okay, here's the so which categories it falls into. So first, it is periodic. There's an orchestration periodic contains multiple time slots, just like the TS, and it is also the flow level. There's a time slot is assigned per flow for interleaving, and it can be seen extend the TS single scheduling traffic queue to multiple slot queues, and it is bounded the time is within the outgoing time slot. And so finally, it falls into the flow level periodic bounded category. And here's also lists some comments before, but we also didn't receive any comments from the last meetings. So it is same, just find the opportunity to be adopted. Okay, someone in the queue, please.
Florian, please.
Yeah, you can see it.
Me again. A different question. Do you plan to assemble a Yang model for this? Because that would really help me to understand which of the things of the standard are really needed for configuration and which is more like, yeah, explaining the principles behind it.
Yes, I think both. You ask about the mechanisms, or
I'm asking if you plan to create a Yang model for this standard, for the configuration of this.
maybe, but at this stage, maybe we haven't created a Yang model for this draft.
Okay.
Okay, thank you very much.
Okay, thank you.
Yanchal? Yanchal? I'll get it. Oh, is that you?
No, but I can.
I'll
I'll
get
just
it.
stop the timer.
Hello everyone, my name is Yunchul Liu, working on F3. I will be presenting the on-time forwarding with push-in first out queue.
Should be working.
In this update, we identified the appropriated suitable category for on-time forwarding along those defined in the taxonomy draft and update the contents of Chapter 7 accordingly. So on-time forwarding method belongs in the number 4 flow level non-periodic bounded category. I will briefly explain why it belongs in number 4 category through its operation. This is three-put from three-put comes in 3 different flow and going out 1 put. When a packet arrived, the on-time forwarding method determine the minimum departure time and maximum departure time based on the node delay upper and low bound assigned to each flow, and packet transmit within the forwarding budget, which is minimum after minimum departure time before the maximum departure time, and in ascending order of their nominal departure time. So our on-time forwarding mechanism is flow-based bounded category. To guarantee the packet forward within the minimum and maximum departure time, we need admission control is required to determine whether the forwarding budget is sufficient. So we performed the on-time service testing across the 7 nodes in actual current node over a 1,190 kilometer section between Seoul, Daejeon, and Busan in Korea. the test confirmed the over 10 kilometer long range. We can guarantee the on-time service within the almost 10 microsecond jitter. And we plan to multipass test using the full flow, which is different path and different distance. And we wanted to verify the full flow, achieve the same maximum and minimum delay requirement, even the different routing condition. Thank you. Any question?
Shafu, please go ahead.
Thank you for this presentation. I remember you have another solution that is unscore, right? So
Yes.
my question is, I think, can you tell me what's the difference between this solution and the unscore? Especially both of them use the PyFOQ.
This solution is time-based solution, and on time needed to meet the very low jitter on time requirement. And next, N-score is a rate-based solution that is on-time solution, but jitter was controlled by that rate.
Okay, thank you. So
Switch to the next presentation where you explain more in detail.
Okay. Next is non-more conserving stateless core fail queuing and score. Identify the appropriate suitable category for N-score and updated the contents of chapter 7 accordingly. N-score belongs in the number 2 category, flow level rate-based rep-bounded category. N-score, when a packet arrives, determine the service period based on the service rate assigned to the each flow, like this. And then packets are transmitted after the eligible time. So we can call N-score belong to the left-bounded solution. And that service period is calculated based on the rate-based. So N-score is a rate-based left-bound solution. And ascending order, the packet are transmitted according the packet are transmitted in ascending order of the finish time, but this is not bounded time. N-score is only have one admission condition that the sum of the service rate are less than the link capacity. We plan to implement the C-score and N-score on real system. C-score include C-score and score data plan function based on the FPGA and SDN controller based controller function controllable function is that automatically calculate the rate and that meet the user requirement and perform the automation control. Thank you.
Any questions? Thank you for the presentation.
Torlis?
Oh yeah, this is really
Yes.
an experience. All right. So at the ask at the last DETNET interim meeting was let's try to progress the taxonomy draft by attempting to apply it to all our drafts and see how well that works. And I'm also author of the taxonomy draft, but here in the mic just as a working group member and author of the other 3 drafts. So would also like to exchange thought with the working group before we're adding what I'm suggesting as maybe improvements to the taxonomy. And yeah, I've also not added the classification results to the draft because I may also misunderstanding some things. So TCQF, variation of CQF with the cycle number in the packet to make the required clock accuracy significantly less strict than it is in CQF, and hence that we can increase the speed to hundreds of gigabits without having to increase the clock accuracy 100 times. So the dominant factor for the latency bound seems to be the sum of the max burst sizes divided by capacity. It is a periodic solution. The traffic granularity is class-based, which because there are multiple classes of these cycles. And then time, yes, it's bounded. It's cycle time bounded as the detail. And the service order is, and I think that's one of those points I had in the slides later on. I think firstly priority and then arrival, right? So listing the 2 different parts that make up the arrival time. Then the GLBF, that's a damper-based solution. It's an asynchronous solution and specifically also combined with the ATS calculus so that we can show that we have proven that we can get away with a very simple lightweight FIFO-based hardware implementation. The dominant factor for the latency bound is 3, so it's the sum of the maximum burst size capacity. It is not periodic. It does also not require clock synchronization, but just frequency synchronization in the order of, for example, what we currently also need for Ethernet, meaning plus minus 100 parts per million on the frequency of the clock. The traffic granularity is class-based. The time bounds are bounded by the clock frequency accuracy and proportional to that. So yeah, and then the service order, it's priority. And yeah, so I'm not quite clear how we describe the service order for something like a damper here. So there were no good guidance in our current document. So I put the non-existing keyword damper here, and that's one of my points in the criticism. Maybe I'm just not understanding what's meant, but then maybe we'll just add helpful explanation in the taxonomy for stupid people like me. So then we come to the really interesting, difficult piece, I think, as far as classification is concerned, because the flow interleaving is a network ingress only function. It is not meant to be performed like the others. Oops, sorry, hop by hop, but it is only meant to be done on the ingress to pretty much create aggregates of flows. And it is applicable to all the mechanisms that we have, I would think, that are category 3 and tightly bounded latency, meaning those that very strictly forward packets after an on-time latency hop by hop. So that they experience almost no jitter. So obviously the two drafts that I were presenting, TCQF and GLBF, they do fall into this category. Others that we have here pending as well. So this draft would be applicable to multiple of those drafts. So, and it's not a solution by itself because it's ingress. It is periodic, it's flow-based, and the time bound is bounded by a large management interval. And the service order classification, again, is unclear to me. So yeah, so that was the attempt. And with that, I basically identified the following issues and partially improvements, right? So I don't think we have a classification based on whether something is hop by hop or ingress only, and maybe anything that's ingress only we take out of the whole picture, right? Because we had already in before separate documents for aggregation, for example, and you could call the ingress only functionality something like aggregation. The traffic granularity, so for the purpose of comparing scalability, maybe we shouldn't consider what currently set as the overall, but the worst one, right? So section 5.2 says ATS is class level, but I think ATS has this really prohibitive property of per hop, per flow lookup state, which really doesn't make it scale in large scale networks, right? And we can't really express this. And so yada yada, there's some text suggesting how we can maybe change this. But I think that's a key thing that we expose more clearly when we actually do have state on every hop or not. 5.3, text suggestion, bounded solution have strength to avoid burst accumulation and are also benefit for jitter control. And I think that another big benefit is allowing higher utilization due to interleaving, which is possible. Sorry, is there a question?
I suppose Gino's reflection is to this slide, so maybe it's good to take it now.
Yeah, of course. Yes. But just let's make sure we're not running out of time because we can...
Yeah, thank you. This is not a question, just a comment. I think the first suggestion about the hop by hop and ingress only classification is not applicable, I think, because, you know, as you can see, as you have said in the previous slide, your ingress only solution does not guarantee the latency bound. It requires solutions inside hop by hop node. So I think ingress only solution is not applicable.
No, that's fine. But I think that turns back then the question of what do we do about these ingress things that we want to have so that the hop by hop solutions can have higher utilization.
I agree to you that if we make our ingress traffic smoother, it is very helpful.
That too, right?
Yeah,
so
I totally agree, but it's just a part of the solution. It's just part of the solution. So it has to be included in the solution as a part, and then whole solution can be considered as a candidate for the suitable category. And in that case, your suggestion for the further classification is not necessary, I think.
But then we have to duplicate all the different ingress functions we can do to help with each of the possible solutions. So to me, I think the modularity would be a lot better that we think about adopting the ingress add-on functionality.
Yeah, I understand. Your suggestion makes the whole DETNET working group into a headache because our solution has some components at the end, at the entrance of the network in the core. So it is a set of functional entities, okay? For example, as you just said about the ATS, it has the interleaved regulator at the beginning, and then it has a cluster level queues, and then a strict priority scheduler. So it is a whole set of functional entities. We call solution the whole set. So when you say solution, it is just a whole set.
Well, I mean, we already...
This is quite fundamental. I suggest to continue on the list and to see your next slide because of time as well.
Right, so service order. maybe better define that the service order should be specified as a comma separated list of the different priorities that impact the service order instead of a single one. That's what I thought after going through the two first versions. 5.5 mentioned time-based as an option. So there is text about time-based, but it doesn't introduce with any text what time-based means. So I think there is some text missing. Section 5.5, right? So the damper for GLBF, it's unclear to me how to characterize that. And then section 7, so my feeling was that the examples given did not have enough flows to show, for example, the higher utilization that I can achieve through the combination of the flow interleaving and then the cyclic forwarding. So I guess I should probably come up in the first place with such an example and show that classification with that. But maybe then it would be useful to bring something with more flows where that aggregation benefit can be shown into the section 7. Yep, and that's it.
So further questions, comments? Right now. Okay, let's move on to the next one. So, Kwam, please.
Did we lose that screen?
Oh, yes. Maybe it is connected to this one. And
this is.
that's
Oh.
okay. The other one is
Oh,
nice coming back, but you can see it from here.
okay. Okay. This is Chuan Shong from ZT. I will talk about the enhanced use case for scaling deterministic network. This draft has been presented at last meeting, and thank you for the comments from Gino, Carlos, New, and Yellows. And we have done some updates to resolve the comments. For example, we merged the section 3.5 to the section 3.4, and we update this use case to improve the scientific research section, and we also add some simulation results to verify some requirements of the use cases. So this is the comparison from version 3 to version 4. And we especially propose the use case for scientific research. This is, for example, it is proposed the new the long distance and the massive data transmission. It will lead the massive research data transmission between the two centers, such as the HPCs. The distance will range from the 100 kilometers to 1,000 kilometers. It will demand data transmission from a few Tibets, and it also. Sorry. Thank you. Thank you. So it demands some high performance requirements such as the bandit latency, and it is especially demands some ultra low or zero packet loss. So to verify the performance requirements, we do some lab simulation or the testing. For example, we do some lab simulation from the impairment emulator to verify the use case with the variable latency, the jitter, and the packet loss. We want to test the impact of the deterministic latency, jitter, and packet loss. We also do some sanity testing from long distance, for example, from Nanjing to Beijing, and then it may be across 2,000 kilometers wide area network, and it will achieve the deterministic performance for the high throughput transmission and the low latency RDMA operation. So the first one, we're testing on the long distance and the latency. This is the testing results of the throughput. We may see that as the latency increased, the RDMA message size length must be increased, but it is limited to some hardware limitations, so it is required to provide low latency. And the impact on packet loss and the latency, as the figure show, that it is difficult to achieve the throughput over the 70%. So the latency and the packet loss over 90% throughout of 100G link. So the packet loss rate lead in the data center must be less than 0.005%. And when the latency increases, it will requires the network to achieve ultra low packet loss. And the last one is the latency and the jitter. This is the data the result data, and the simulation results. It specified that 1 milliseconds and 100 microseconds jitter results overall the performance comparable to 2 milliseconds latency with the 0 jitter. So this is the summary of the results. We can see that if just this long distance and the latency, it will impact the message size, but message size is limited, so we need to decrease the latency. And when the latency and packet loss both appearance, it will impact the throughput. So the result is that the packet loss will be better to less than the 0.005%, and the latency and the last one is that the jitter may be better to less than hundreds of microseconds. So these are the just the simulation and the testing. So we want to improve to prove that the use case will requires the bandwidth latency and the ultra low packet loss. So comments and the suggestions are welcome.
Yeah, I have a question. Like, we have a requirements document, the working group.
Yeah.
And have you considered any requirements coming out of these use cases that actually would be good to include it in this living document?
Yes, we have added a subsection to what's new to the IETF request to IETF, and we summarize to new requirement for DETNET. For example, the packet loss and high throughput for DETNET to meet the new requirement. And we propose that the DETNET will need to meet the differentiated levels of the services.
And
so
do you think this current requirements document would be a good place for that? Because what's behind my question is, we have a living requirements document, and maybe we would not open up another one, just capture all coming requirements in one document.
So DETNET didn't accept a new requirement.
The data
That-
plane, the data plane enhancements has a requirements document that's an active working group document that anyone in the working group can contribute to. So the suggestion is read that document, and if you'd like to see changes to it, propose those changes on the list.
Okay. Okay. Thank
And
you.
you can take it from this document, which is an individual document, and get it into a working group document.
Yeah. Okay. Thank you.
And Shafu, please go ahead.
Shafu?
Sorry, Peng Liu. Sorry, I'm very sorry.
You may want to list what you want from your draft to IETF, to the networking group, and also to the requirement document from your draft, I think, because it includes several aspects that you maybe in the previous slides. So just to make it clear what you want from IETF, from DETNET, or from the requirement document.
Yes, we have some new use case and some new requirements. I want to ask her if that is in the scope of DETNET.
And I think it would be good to discuss on the list.
Yeah. Okay.
With the whole working
Of course.
group.
And in particular, look at the requirements document and suggest changes to it.
Yeah. Okay.
So rather than just say, hey, I have this thing I'd like to talk about, say, I'd like to change the current document to say this. And that by having a very specific discussion on text, it will help the working group focus on what it is you're asking.
Okay. We'll kick off the discussion on the list.
Thank you. That'd be awesome.
Thank you. Yeah. Last is mine. Last is mine too.
Yeah. Anything else?
No. Last slide. Last presentation is also mine.
Oh, yeah.
Yeah. Right? Yeah, data plane.
Yeah. That's number 10.
Okay. This is talk about the state fields for DETNET enhanced data plane. So as we just discussed, there are some queuing solutions, and based on the solutions, the taxonomy Gino has defined the 7 suitable categories. So based on the progress of their taxonomy documents, and there's some new queuing solution documents, the draft would like to propose some metadata for the data plane solution to carry in the data plane. For example, in the scaling requirements document, it proposed some enhancement data plane requirements, such as the aggregation information and the deterministic latency information. So the document proposed a common DETNET header to carry some options to carry the metadata for the enhanced data plane. And the new version updates to align with the taxonomy document. For example, the deterministic latency information has been changed to the 7 deterministic latency types, aligned with the 7 categories. So each category with each type has different metadata to carry the required information. So this is the deterministic latency option, and we define 7 deterministic latency types and with related information. So this is the same with the taxonomy document, the 7 categories. And each category we defined some metadata to be carried in the data plane. First one is the right-bounded category is it need to be carried the maximum time bound, and the second one is the flow level periodic bounded category. It need to carry the 10 slot ID. And the third one is we need to carry the circle ID. And the fourth one is the flow level long periodical bounded category. It may carry the maximum time bound and the minimum time bound. And the last one is to carry the maximum packet size, the surface rate, and the finish time. And the last one, it will add some eligible time for then the last one. So the another is the aggregation option. It will also carry the aggregation type and the aggregation ID. And for the end-to-end requirement, we will carry the end-to-end budget, delay budget, and the delay variation budget. So this is the metadata we need and the enhanced data plane solution to we have aligned with updated with the taxonomy document, and it's independent of the existing solutions. So I like to ask her that if that is in the last step for the working group.
Okay, Florian, please.
Yeah, thank you. So I'm wondering if this is the right approach or consensus in the working group to actually put the concrete requirements, like, I don't know, the delay or something like this in the data packets, instead of having this completely just in the control plane and just have something like a flow ID or so in the packet.
Yeah, the metadata must be carried in the packet in the data plane. It can't be achieved in control plane. Because the two nodes need the cooperation between the carry some information to indicate for example, the queue to which queue or which mechanism to.
Maybe I can make my comment and that you stay there.
Okay.
I stay at the mic just in case it helps. So I agree with the first bullet, and my read of the first bullet is that now we are sort of getting to the down selection of queuing solution with adoption and so on, and having a view actually what do we want to do. And that's, I think, before figuring out what data plane modifications we want to do. And as I understand the point, and correct me if I'm wrong, is that some solutions require some specific fields, like requirement, but we haven't decided if the group is going forward with those ones. That's my understanding.
Okay, yeah, makes sense. So we will see later.
We will see.
Okay, thank you.
Okay, thank you.
Any further questions, comments to this presentation? Okay, then let's go to the next one.
Balazs?
Okay, so this is a presentation about where we are with a new data plane, the SRv6 based data plane work. We have decided to propose a data plane based on SRv6 because there is no native IP data plane which on its own can provide the DETNET service sublayer functions like replication, elimination, and ordering. Because for those functionalities, you need a sequence number, which should be placed somewhere in the packet. And the SRv6 technology provides the possibility to add additional information to the packets. And that was practically the trigger for these SRv6 DETNET data plane developments. So just some summary about the history of this draft. We are currently at the version 2 of the draft. And we have here in that network group draft that is scoping how to leverage the existing IPv6 encapsulation in order to use DETNET specific seeds. It does not mandate as mandatory to use other SRv6 capabilities like traffic engineering, but of course you can do so if you intend to do so. Regarding the seed-specific endpoint and transit behaviors, this is defined in a different draft, and that draft is for the Spring work group. There is also another draft in the Spring work group, which is dealing with redundancy protection. I will later on speak about the relationship between these two drafts. But back to the DETNET workgroup specific draft. So during the presentation, as also after in the floor discussions, we have received a lot of good comments, and we have received a lot of clarification questions. So of course, we have fine-tuned and updated the document, and we have decided to add an appendix to the document. And this is what was added to the new version. And that is showing a detailed illustration of the usage of the DETNET specific seed. And of course, it is done in a so-called multiple pre-off scenario where you have at multiple points in your topology wanted to make replication or elimination functionality. This is just showing the main building blocks for the proposal. So first of all, it is based on a DETNET specific seed format, which allow to add the sequence number parameter to the packets. The second building block is that it is defined how to place the flow ID and the sequence number to the argument part of a DETNET specific seed. And the third building block is describing the behaviors of these DETNET specific seeds. There are segment routing endpoint behavior, and there are various segment routing policy head and behaviors defined. So what was added in the latest version? This slide is just showing that. So this is showing a network where you have a mix of SRv6 capable and native IPv6 nodes. And there are multiple replication and elimination points. We have 2 replication, 2 elimination points in this network. The appendix describes in detail how the pre-F actions act on the various nodes, and also provides details about the encapsulation, what information is stored in which part of the IPv6 header of the packet. And in order to show that it can work in a mixed environment, between the first replication point and the second replication point, we have a non-SRv6 capable network segment. So here you cannot use, for example, traffic steering functionalities, but that is not needed on that part of the network. And you are using the DETNET specific seed just in order to add the pre-off specific parameters like flow ID and sequence number to the packet. Whereas in the upper part, which is just shown with a green arrow, between the replication and the elimination node, we have an SRv6 capable network, and here some traffic steering is also used. And we have shown how this additional traffic steering can be used in addition to the DETNET specific seed usage in these network scenarios. And of course, any of the link can be replaced with a SRv6 network segment, but it is optional, as just said. So this is where we are currently with the draft. We are still seeking for feedbacks if there is need for any clarification. So we would be very happy to have those feedbacks. And we have also started to work on the definition of the pre-off seed. This is the seed what you are needed in order to place these parameters to the seed in the argument field. And as I already mentioned at the intro, there are 2 drafts in the Spring work group. The redundancy protection solution is somewhat specific. It is not able in its current format to cover all the DETNET specifics. So we have discussed with the authors, we sit together also in this meeting before in the earlier part of the week. And we have decided that we should get technically closer, these two drafts, merge them technically, and we will work on that. And the plan is that for the next IETF meeting, we have just a single solution regarding the behavior of these DETNET specific seeds. That's it. Any questions, comments?
Thank you. Thank you for the nice presentation. I have two questions, just questions. One is that although this document is titled as data plane, I think it only deals with pre-op function. It only deals about the.
Yeah,
that's right.
This DETNET specific seed is focusing on the pre-op functions.
Okay.
What is needed for the replication elimination? It is not in scope to have also latency related parameters like I guess you are asking for.
Okay. One more thing is just from the pure curiosity. If you see the slide 4, there is an example network with the elimination function implemented in the middle of the network, for example, E5. I think, so you have to buffer all the packets from a flow that coming from different paths. And then after you make sure that one is received perfectly, then you have to remove the other, for example. Then doesn't it need too much buffer space?
No, because you don't have to buffer it, because it is always the first packet wins. So if you have a packet with a sequence number and you are receiving it over various paths at that elimination point, you will forward the first pieces of that packet, which has that sequence number. It is forwarded immediately. You do not buffer it.
Yeah, the reason I thought that way is that in order to make the jitter minimal, I thought you have to buffer them, all the packets, and then I thought you have to transmit them after all the packets are received. That's what I thought.
Yeah, jitter is a latency related parameter. Pre-op is just focusing on resiliency.
Mm-hmm.
On
But if that is the case, I think you have to have an.
Just let me finish.
Okay.
Let me finish. So,
sorry.
If you would like to de-jitter your flow, this is a absolutely valid requirement, but you don't have to do it at each of the elimination functions. Mm-hmm. Maybe you would like to do it close to the destination.
Right, yeah.
And that is the point. And this is why let's separate them. They are orthogonal to each other. You can use that jittering. You need the buffering for that, or you can do this replication elimination without buffering. Yeah. Okay. And then you have separated them.
Thank you very much for the clarification.
Yeah, good question. Thank you.
Luis.
Luis Contreras from Telefónica. I will elaborate more in the mailing list, but just to comment, because we are using some routing version 6, I guess that this is conceived for being used in the wide area network, where we can find higher speed interfaces, 100 giga or even more. And my point is about the size of the sequence number. So because we are using these higher speed links, probably could be situations where we can turn over the counter of the sequence number. So probably it's necessary to provide some guidance about the size of the sequence number, because depending on the difference in the length of the links, could be the case that we turn over the counter and basically this will not work. So I will elaborate more on the mailing list for commenting there.
Okay, so just regarding the sequence number, we have the standard already specified 16 or 28-bit of sequence number, and exactly those sequence number are used also in this SRv6 based data plane. But let's discuss it.
Okay, I think I'm last in queue. where do you think, if you can go to the one that had the spring documents on it, I think it's second to last slide. Where do you think you are in the process of bringing this into the spring working group? Because what you're sort of informing us that you're doing this, but the work you expect to be done in spring, correct?
Correct. So all drafts were already presented in the spring working group. And then we have also identified this overlap between the drafts. And this is something that we intend to fix in the next meeting, practically.
Okay. I think it's been a while since you presented. Are you planning to present the change at the next working group or bring it up on the list?
Yeah, definitely.
Okay. I suggest having the discussion in email would be very helpful. And I don't know if it makes sense to CC, probably just makes sense to forward the discussion to here, so anyone who's interested can go on to the other list.
Yeah, usually
I did have a conversation with one of the spring chairs, and they really want to see this discussed on the list.
Yep, definitely. And usually for this, we are always addressing both our group in this discussion.
Yeah, it's okay to forward and have the discussion there. You don't have to hit both lists, just forward it so we know what's going on.
Okay.
All right, thank you. Appreciate it. Luis?
Thank you. Hello, this is Luis Contreras from Telefónica. I will present this draft that is basically a draft being presented in or being elaborated in the PCE working group. And it's about the usage of path computation, the PCE, the path computation element, the PCE, in order to calculate paths according to precision availability metrics. And we are bringing here, because we think that could be of interest for DETNET, and we would like also to receive comments from the working group. So basically, what is the idea behind this? So we have the path computation element, which is able to calculate the paths according to different metrics. By now, the metrics that are being defined are somehow static metrics, in the sense that you get a snapshot of what is happening at the moment of the path calculation, and you are allocating the path according to that precise metric at that point on time. So what we intend with this extension is to consider the behavior of the path along the time, along the lifetime, along the time. So basically, collecting metrics that and creating a statistical behavior of the path in terms of being defined in terms of histogram or CDF, or so that we can somehow ensure that the metric that we are looking for is according to the expectation from the customer. This is basically, we are working on this because some services will be expressed in terms of SLOs, so considering long-time behavior, and that could be the case of the net services, but also other services like the network slices and so on. The precision availability metrics is an outcome from IPPN working group. It's in RFC 9544. And yeah, what we intended here is to create propose an extension to PCE for handling these precision metrics. So a rationale behind the applicability of PAN, as said, the characteristics of a link or a path could be expressed in terms of the statistical behavior. There is here at the bottom on the right of the left, you can see a kind of histogram. So we can define different intervals of violation of the different bins that are being that characterize the expected behavior by the customer, and also severe violation intervals. So the point is basically trying to accommodate the description of the expected behavior of the path in this way, and that the PCE can calculate that. The idea would be that all the metrics, all the information is being handled by the traffic engineering database, so that let's say we don't consider the burden of that storage in the path computation element, but in the TAD, so the path computation element, once received the request from the client, can check against the TAD what could be the potential paths that accomplish this statistical distribution. I will not enter in the details of the format of the message, but basically we try to enable the possibility of expressing the behavior of these statistical formats in the TLB. So as examples of precision metric usage, for instance, in case of having a two-tier delay SLO, if the service is expressed in terms of that the 99.9% of the packets has a threshold of 20 milliseconds, and the being 25 milliseconds the critical threshold, with a violated ratio of 5%, severe violated ratio of 0.%, and so on so far. So yeah, we are trying basically to accommodate this kind of services, or even multi-tier statistical distribution, more in line of the histogram that I expressed before. These formats are coming from the precision availability metrics draft, so it's in RFC 9544. Yeah, basically this is, that's the point. Apart from the formats, we are also proposing some extensions on the messages. Maybe this is not relevant for DETNET, so I will skip that slide. And then, as I said, we have presented this in PCE. Is how we are receiving comments from there. We presented also today. We have presented in IPPM as well, receiving comments from that working group, and we intend to do the same from DETNET. With all of this, we will prepare a new version, and our idea is to ask for adoption in PCE working group, but it will be very interesting if we have also, we receive input from here. That's all from my side. Thank you.
Thank you. Comments, questions? The queue is accidentally locked. Let me unlock it. Torlis?
Thanks a lot, Thales Eckert. It's late in the week, so maybe I didn't catch all the details, but the precision was still probabilistic things, right? So
correct.
We're trying to avoid those in terms of deterministic things. So any way on how you could give an example of how they could actually match to some DETNET service, I guess. What is it? Working okay, but really not good, versus working failed, right? So that, I think that's the purpose, right? So having these type of distinction.
I'm trying to get to the examples, but I'm not able to be projected here. Yeah, certainly here we will not have a full deterministic behavior. We will have this statistical behavior.
Mm-hmm.
This could be of applicability mostly for wide area networks and so where we cannot have strict guarantees, so something approximate. So as long as we can define the behavior in this statistical manner, the idea would be compliant with that as much as we can. So you can imagine a lot of nines there and challenge the network, the wide area network, if it's able to comply with that or not.
We love 100 here, right? So
no, not actually, because wide area network has a statistical behavior, so we cannot provide 100% of guarantees.
Is that okay? Greg Mirsky Erickson. So I'm probably coming to this from IPPM working group perspective, co-authored on this RFC 9544. So yes, I agree with Luis. Well, again, even for DETNET, there is no guarantee. We try to ensure on-time delivery and very low packet loss by doing pre-auth, for example. So guarantee, at least there are no guarantee. So here, yes, you can have 5 nines, you can have 6 or even 8. Okay, so basically that the PAM is the framework for expressing some statistical state as availability and stability of the particular path given their required SLA, which is a combination of multiple SLOs. So you have multiple service level indicators, you set the thresholds, and basically that's your criteria for selecting path, which the most stable given your requirement for the quality of service.
Yeah. Thanks, Eric. Yeah.
Thank you.
Okay.
Thank you. Thank you. And I think Carlos, last up.
Okay, thanks. This is Carlos Bernardos, and together with Luis, and we are going to shortly present some lessons learned or some summary of what we did in the hackathon. This is basically an effort coming from different projects, and let me be also honest and fair. We also took the opportunity for the hackathon to be in Madrid to try to also show what is the IETF to some of our students. So that is a kind of a double goal here. One is to do something for DETNET because we are working in projects. The other one was let's try to bring students in different ways. One was to do this hackathon experiment or project. Another one was to also do a visit to the NOC. So this comes from three research projects that we are working on together with Telefonica. One is Predict6Z, which is about mainly enabling multi-domain deterministic networking. And you have seen in previous IETF meetings that we have been contributed with some drafts, and we plan to continue doing that in the future, although the project has already finished. And the other one is this RCC that also tries to enable some way or some kind of deterministic, but in this case through the programmability of the network. And we also have a national project that is also working on multi-domain deterministic networking. So we have two challenges here in this hackathon. One was basically to try to extend the implementation that we have from the Predict6Z project on the data plane. We have an MPLS compliant data plane implementations there, traversing multiple domains. But in the case of what we have in the project is basically configure statically. So you configure a topology, given a scenario, you push there or you put there a JSON file with the configuration for the pre-auth and all these things. And okay, it works, but it's statically configured. So we took the opportunity for the hackathon to try to do some simple way of implementing this with a controller intelligence, very simple controller intelligence, and a REST API for pushing the configuration into the network. So the guys working on that managed to do so in a simple virtualized environment, but this can also work in a real deployment. So that's that's a first result from the Predict6Z project on this REST API implementation. It may be that in the future, depending on how the work on the control plane framework goes in the DETNET working group, we may also provide more details and continue working on that, as this is basically a working scenario where we can play not only with this simple approach, but with whatever we do in the working group in the future. And then I pass the ball to Luis.
Thank you. In this second challenge, we were proposing to work on a dissector for Wireshark so that we can understand, let's say, on the wire, what is the kind of messages that we are receiving. This was focused for being able to also to understand the headers of the inbound telemetry capabilities. So we basically, what I'm doing is together with P4 inserting inbound telemetry capabilities so that we can monitor the status of the path. So we were working on that. Unfortunately, we were not able to complete the job, but this is somehow we have is a work in progress, let's say. And interestingly, we were working with the help of AI agents in order to understand the RFCs and produce, let's say, some initial seed of the Wireshark dissector. So in summary, it's not available yet, but we will be available soon, we guess. And the next idea is to contribute to Wireshark with this dissector so that the community can use it as well.
Yeah, and just the last slide, just to acknowledge the guys that actually did the work, the team, the students, which are the real champions of this. We are just presenting what they did. So thanks.
Florian, please.
Just a quick question. Why REST and not Yang?
Just to do something quick and dirty.
Okay.
Yeah, that's the only reason, yes.
Okay, great. By chance, are you at the workshop tomorrow?
Sorry?
Are you at the workshop tomorrow, maybe?
Yes, yes.
Okay, then we'll
sure.
talk about that.
Yeah, I was hoping that you were going to say that the REST API was the Yang model encoded in JSON. So I'm disappointed to hear that.
Actually, to be fully honest, I'm not completely sure how they did it at the end. We can discuss tomorrow. You can ask the guy, because it may be that they did something, because we were discussing for sure on that on the use of Yang. So I'm not sure what we did at the end.
Okay, great. Blush?
Okay, just a short question about your first scenario on this configuration. So why it is usually pre-configured is that if you are doing change in the configuration, you usually risk that you will lose some of the packets. So have you considered that part as well during this work?
Not yet, not yet. Because in the scenario that we have in the project, we were more concerned on trying to use a multi-domain with different technologies. We are using 3GPP, sorry, 5G, TSN, Wi-Fi, and that was the goal with other things, but in a static scenario. So next step was, okay, let's try to be able to, even if the scenario changes, to be able to push the configuration in a simpler way. Next steps will be do that. Would you suggest? Yes.
Okay.
To be able to dynamically reconfigure and ensure that things are not broken, and we try to minimize, well, or have no losses and all these things. Yes.
Yeah. Please share the results on the list.
Yeah,
Thank
sure.
you.
Thanks. By the way, the implementation of data plane and everything, I didn't put the link, but it's available. You can ask me. So in case you want to play with that, it's available open source.
That's great. Send it to the list. Definitely be interested in seeing that. So here's where we would normally say thank you. Oh, I'm sorry. There's one more person in queue.
Here. Well, just it's a generic question, not about the hackathon itself. Because the hackathon mentioned about the multi-domain testing or experiment here, but this is more the question toward the chair. What will be the plan or strategy for the cross-domain work? Thank you.
So I think the first thing is we have to agree on what a domain is. Because I think if we ask each person here, we're going to have different definitions. Carlos has started writing a document on multi-domain, so hopefully that will progress into the place where we capture that and start fleshing out the agreement. As always, we're contribution driven, so if you would like to work with Carlos on that, that would be great. He's at the mic though. You might want to respond.
Yeah, just to quickly complement or add on the answer from Lou. We are working on a potential on a draft that we plan to submit before Montreal and ask for presentation. Continuing on the discussion that we had in previous meetings, so we are trying to basically look for a generic framework with based on PCE, inter-PCE, and work on that. So that's in the pipeline. If you want to join us, just contact us and we can add you to the loop. Okay. We are happy to work with you guys as well.
Sure. Thank you.
And I know it's a challenge for all of us to get drafts in early, so we can even, but I'll remind you, we can always get a draft in early and discuss it on the list, or even have an interim or less formal meeting, if that helps. But I know deadlines always help to get us to publish. So back to what I was about to say is this is normally where I thank everyone for lasting to the bitter end on the last day, the last minute of the IETF, but we have tomorrow. So instead, I'm going to say I look forward to seeing you all in our session tomorrow. And if we don't, we'll see you at the next IETF. Thank you for participating in a successful session.
Yes, thanks everyone. And there is the farewell reception. Maybe not so bitter. Thank you. See you next time.